So I'm Dennis Brown. I'm here today to talk about resilient botnet command and control with Tor. I came up with this title while working on the CFP at the very end of the deadline, and yeah, it's probably a bit dry, so I decided I should probably rename this talk to something a little more fun. So here's the new title screen. I think it's the point across about like Tor and hidden. Okay. Yeah, it has. I'll take that as a compliment for my wonderful Photoshop skills. So who am I? I'm Dennis Brown, like I said. I'm a security researcher for Tenable Network Solutions, which if anybody asks me, if they've been asking all week, that I'll just say I write Nessus plugins. It doesn't really matter what I do. I've spoken a few times at TorCon. I spoke yesterday here at DEF CON about something about as far from this topic as you can get. So this is a nice change. If you've been following me around, thanks for being a groupie. I'm also part of a Rhode Island DEF CON group, DC 401. Anyone here from Rhode Island? Yes, that's all of us. So that's what I am. And what I'm not, is, in the disclaimer there, is I'm not affiliated with the Tor project at all. I want to make that clear up front. I have nothing really to do with them at all. In fact, I really want to say that I love Tor a lot. People might be thinking, oh, you shouldn't be doing bad things with it. I agree. It's a really great tool. Most of the people that use it really aren't using it for bad purposes either. I mean, I don't know if any of you follow the stuff going on, like people trying to get to websites from China, Chinese trying to block Tor access and stuff like that. I know last year when I was following the election going on in Iran, it was wonderful seeing people using Tor and other proxies to get the word out, get all kinds of information that's going on in the Western world at least. So I really do love Tor, and I don't want people to really think that I'm just trying to use it for my own evil purposes, because I'm really not. I'm trying to make us aware so we're not doing it for evil. But just like any good tool, it can be abused. Just like anything else. Anonymity is great for us. It's great for people who need it, for people who are oppressed, but it also is good for people who want to do bad things. So it's how it is. So here's a little overview of what we'll be talking about today, or I'll be talking about today. We're focusing on botnet command and control, specifically command and control, but a few other factors around it as well, because there's a lot of interesting things we can do with this. I'll be doing a few case studies, or a case study using Zeus, or ZBot, or whatever you may know it as, and talk about a few theoretical models inspired by some of the other big bots and worms and whatnot that we've seen over the last few years. I'm going to talk about a few techniques, too, to use Tor to anonymize your servers, because that's really what this is all about. How many people here are actually familiar with hidden services with Tor? That's what I expected, actually. It seems to be one of those features that just more people really need to know about. So you should learn about it. You'll learn all about it here. And the goal of this is actually to keep your servers up and keep your botnets alive, because I'm sure we're all terrible people and have botnets and whatnot. So we're going to talk about the ways this is good, the ways this is bad, strengths, weaknesses, all stuff like that. So you may be asking yourself, well, why is this important to talk about? This sounds like it's just something terrible people shouldn't be doing, or it's awesome, I'm going to go home and do it myself. There's been a lot of discussion over the years in various forums in the research community about people being a little worried that some malware might actually be using Tor. I know there's been several discussions I've been a part of that people are like, wow, if it really did that, this could be terrible. We would never be able to detect the traffic. I don't know if anything like this actually exists, and if anyone does, I'd love to hear about it. I don't know how much research has been done either. I looked around, I didn't see much, so I'm hoping to shine a light on it here. There's a lot more work to be done in this space than I'm presenting today, and it's really just right for the picking, in my opinion. And what's great, well, what's terrible about it is there's a big potential for just devastating impact on networks and computers as we see them today. The technology for this is Tor. It's free to download. Anybody can get it. Anybody can implement it however they want. It's very easy. I mean, I'm sure we've all used it at one point or another and know how easy it is to use Tor. And it's really minimal effort, and you get great anonymity with it, as great as Tor is. And I know there's a lot of people who use Tor for all sorts of purposes every day, and I've never heard of anyone actually having a problem with it unless they did something wrong themselves. And we're going to talk a bit about some safeguards that can be taken to detect this activity. And these have varying levels of complexity depending on the techniques you use, the approach you take, and how you actually implement it all from end to end. So let's get on with some fun stuff here. Thank you, Spider-Man. So I don't know about, anybody here actually have a botnet? Anybody? Yes, thank you over there. And if there's any feds, let's go over it that way. So if So I'm sure we all have, though, for real, but it sucks when your botnet gets taken down, right? Isn't that the worst thing that can happen? Really? You spend so much, it really comes down to time and money that you put into it to get it together and actually make it real and be able to make some money off of it. As far as like spending time on it, you have to spend a lot of time planning this. This isn't something you just spin up overnight and you want to have to like say, oh, I'm just going to drop my malware in a bunch of boxes and collect data. Now you have to spend a lot of time planning it, figuring out who you need to talk to for what services you need, how you're going to implement it all, and how you're not going to get caught. Setting up the servers themselves can take quite a bit of time. If you're buying some hosting from a bulletproof provider somewhere in Eastern Europe, that you'll have to talk with them. If you don't speak the language, that's another hurdle you have to get over. And try to figure out how you're going to get the services from them and how you're going to get what you need on the servers they give you. If you're doing another method, say you're compromising boxes after scanning for SSH passwords, brute forcing them, you're going to have to figure out how you set it up and not get caught that way too. So that's another method you could take, or to actually have a server to put your botnet on. Building the bot itself can be a whole lot of time. If you're coding it from scratch, that could take weeks, months, years to do it just right. If you're buying it, well, you're still going to have to figure out how to use it and how to deploy it. That's not the easiest thing in the world. We'll see one that you can actually just buy in a little bit here. Then there's other things like crypting it so AVs don't pick it up, so you have a different binary every day so you can evade all kinds of detection, binding it, or whatever else you want to do with it to make it undetectable, or load other malware on it like fake antivirus to make some good scratch that way. And then spreading through BitTorrent through BitTorrent is a great way to get your malware out there initially. If you make some cool hack for whatever, for Modern Warfare 2 or whatever, I don't know. Or then that's one approach you can take. That takes a while for it to seed, for people to get it, so it's a big time investment there. Or if you go, say you want to do a drive-by download attack, you go do some SQL injection against some server, see what sticks and doesn't. Well, it takes time for that to happen, time for it to get queued up in a search engine, and ultimately that's a lot of time you're waiting for it to actually impact to the point where you have a botnet of any kind of size that's of interest. If you're doing spear phishing or any kind of spam campaign to spread it too, that's more time you're spending. And if you're not spending time, you're spending money. All of these things are services you can buy, like buying spam services, buying drive-by download services, just saying, hey, I have some malware here, I'd like to get it distributed to 10,000 hosts. Okay, well, pay me however much money that costs these days, and I'll get it out there for you. Next thing you know, some sketchy guy has it done for you, and you have a little botnet of your own. So each one of these things here, it's a lot of money, and you don't want to lose that monetary investment, even worse than losing the time investment in a lot of ways, because then that's just a waste of everybody's time. And when you don't have a botnet at all, if it's actually gotten taken down, well then, you just lost all your income. If you're using that to do spamming, sell spamming services, lease it out to other people who want to do these kind of activities, well then, if you're shut down, then you're not making money, and that's no good at all. Although it actually is really good if you're on the defensive side, which is what I actually am. But so, how do they get taken down? There's a variety of ways. If you have a VGPD pairing, seems to be the best way to get taken down. That's the ones that seem to be the most effective, and more or less. Some of the big examples, Micolo in 2008 was taken down. They were really big in spamming. Actually, there was a short period where there was a big decrease in spam after Micolo was taken down, and while everybody was rushing to find new places to host their spamming. And they were also the host for the main command and control server for the ASProx or ASProx botnet, which once that was taken down, that botnet never really recovered quite the same. They tried to come back a few times, but not like the good old days of 2008. And then Troyac was a big one this year. These guys were interesting because they kept going down and coming back up and having this cat and mouse game between people trying to take them down and new hosting or upstream providers that just said, yeah, come on, we'll host your stuff. We don't really know what you have. They were hosting a whole lot of Zeus command and control servers. I think it was something like, I forget the exact number, it was somewhere in the hundreds, I think, which is a pretty big distribution of Zeus command and control servers. So that was interesting to see how that went off. Another way too, if you're just using some host you popped or something, or if you're using some free web hosting, I know like almost all the HTTP botnets just use a PHP MySQL interface to their command and control. There's a lot of free web hosting now, like 110mb.com comes to mind, where they actually provide you PHP and MySQL. And a lot of people recommend just say, hop on there, get it set up, get it started, and then if you have something good, make some money and buy some real hosting somewhere along the lines. You see a lot of people actually starting out with that stuff. And every so often, the people who are either running the servers that you may have gotten into or running these free hosting providers will clean up sometimes, hopefully, and you may just lose your botnet that way if that's your only place you're hosting it at. it's good to have redundant sites, like you would with anything, and these guys know that too. Having DNS revoked is another great way to take it down. I'm sure we've all read about Microsoft earlier this year, pretty much neutering the Wolodeck spam botnet, where they had to get a court order to remove, I think it was 277 domains that was being used with it. And then since it got down, I don't know if it's come back or not, but that was a great win for them to really stop that one right in its tracks. So that can be kind of hard to do, though, depending on how the registrar wants to work with you. If they're not too friendly, if they're not good to work with, then that might be almost impossible to take it down, especially if they're ones focusing on providing services to people doing this kind of stuff. And that also would include things like no IP and other dynamic DNS hosters. Those guys can be good to work with too, because they can just go and remove the entries they have. So if you have them if you come across a botnet using them, I encourage you to go talk to the people providing the DNS there and get it removed. There's always a case some jerk goes and takes it over. That happens. It gets taken down that way. It's valid. And then there's other cases where the IP of your command and control server just gets banned or blocked or something like that. This also would include things like if your ISP shuts down your cable modem, and you might think to yourself, "Oh, that's awfully stupid. Why do you host your botnet on your cable modem at home or your FiOS router or something?" And then there actually are people that do that. Anybody go to this site, hack forums, on any frequent basis? Anybody like this site? I hope not. That is a pile of shit, that place. Absolutely disgusting. They post up interesting things once in a while. Earlier this year, there was someone who posted the Tweebot, I think it was the Twitter botnet command and control thing on there that made a lot of press. A lot of bloggers posted about it. And it was terrible, and that's really the best thing you get from here. And I love this one page right here. I have an excerpt of. Visit the URL at the bottom for a good laugh, actually. This is instructions on how to set up the Medius Delphi DDoS client, which is pretty much what it sounds like. It's a DDoS botnet tool that you can just go make your botnet with. And part of the tutorial here says this is going to be based off of a Linksys router. So, or if you don't have a Linksys, go to portforward.com and look for your router. So clearly these are people who are underskilled, but if they actually follow this and no one pays attention, then they can do some good damage. But hopefully they don't catch on to better ways to do that. So these guys are terrible. So this is what I think about people actually hosting off using that site and everything. Absolute failure. It said my pen isn't a goat. That's not too funny, right? So we have all these ways that can get taken down. That's no good. What can we do about this? Well, let's see what we can do with Tor. So I mentioned hidden services earlier. I'm going to explain them a little bit more here. So what is a hidden service? Well, they've been in Tor since 2004, and what they do is allow a user to run a server anonymously. When you do this through Tor, you get a domain with a .onion TLD, and the domain itself is just a randomly generated hash. There's more to it than that, but it's essentially a hash.onion is what you would see, and that would be the URL for your server. And these are only routable through Tor. So if you try to go to it directly without Tor, obviously it won't resolve. If you go through Tor and use an HTTP proxy or some other ways, then you'll actually have it'll actually resolve and you'll be able to connect to the server just fine. Now what's sweet about this is it works pretty much anywhere you can run Tor. So if you have a box that's natted behind something behind a firewall, somewhere where it just can't be accessed from the internet directly, you can spin this up and actually get right through it because it goes directly through Tor. This means there's no need to expose anything to the network. If you have a web server on a box, you don't need to open any ports or anything, or have even locally on the network, you can block it off completely. It doesn't care. It's all running just on the same system. And this is great because we can use this to our advantage to stay hidden. And but there are a few catches with this. A lot of the web command and control panels are kind of poorly written. A lot of them are just PHP applications, and we all know there's not many problems with PHP. So there's a bit of research done a couple months ago. Actually, I don't have notes on who did it, but it was but they actually found several vulnerabilities in many of the web control panels for, I think there were the web exploitation toolkits. I don't know if Eleanor was one of them, but things of that nature. So if you're hosting something like that on a hidden service here, be careful because you may expose your IP inadvertently, or if somebody can drop like a C99 shell on there, and then you're really screwed. One thing I like to do when I'm doing things involving hidden services is make sure my host box itself is behind a Tor transparent proxy. So if somebody does do something where they try to expose my IP, hopefully they're just going to get some Tor exit note somewhere. But that's a whole other discussion. But I encourage you to check that out too if this is interesting to you. So hidden services, I'm not going to do them justice for how I could explain them. The Tor guys have this stuff, have excellent, excellent documentation on hidden services. So I really encourage you to go to the Tor project website. The URL is up there, but it's really easy to find if you search for it, and check it out. They have great documentation both on how it actually works in implementation and how to configure it. I'll give my 2 or 3 line explanation of it, which probably is incorrect, but I would encourage you to read that instead and don't listen to me exactly. But essentially, when you start a hidden service that advertises to the Tor network and uses a public key in order to communicate with relays, the first relay it communicates with will be its induction point to the network. Essentially, what that means is if somebody wants to get to your box, they have to get to him ultimately to get to your to your hidden service. And if anybody connects to the Tor network, they're going to go through and say, hey, I'm looking for this .onion domain here. Ultimately, someone will say, oh, just talk to this host here. This is where you want to go. That's a really poor explanation, but hopefully that gives you an idea of how this all kind of works. Not really kind of. So just to show you how simple this is to set up, I have a couple lines from the Tor RC sample they provide that shows you all it takes to set up a hidden service. There's 2 parts. There's a hidden service directory, which is important because that's where it gives you the actual host name for your new hidden service or hidden service server, and the private key so people know to communicate with it, be able to trust it, and be able to use it ultimately. And then the other line is the hidden service port. This is very simple. It's just like creating a firewall rule for many different firewalls out there. You provided the port you want to run on. In this case, they're using 80, so I can pretty much assume it's a web server. And the web server itself on the system is running on localhost port 5222. Once you just put those in your torrc file, restart Tor, and then everything will work just fine. So there's one paper I want to mention called Locating Hidden Services by, I'm going to butcher their names, Overleer and Syverson. I'm sorry if I butchered them. I really recommend checking out this paper. It's a very good paper that they did a few years ago regarding introducing malicious Tor nodes into the network to try to actually expose the hidden services, or the servers running hidden services directly. It's a pretty long paper. I would actually encourage you checking it out if you plan on using hidden services, just so you're aware of the risks that actually could come into play. It's a few years old now, so I'm not sure if it's all 100% accurate, but I think it's still worth a look because it's probably not far from where we are today. If anyone knows any further on that and wants to correct me, please do, because I haven't looked at that too much at all. So I'm going to change gears here for a little bit. So I love this image because it pretty much sums up how I feel about when you combine Tor and Zeus. If you can't see it too well, that's a skyscraper-sized Chuck Norris fighting a equally huge Mr. T with the caption of, God never intended for these two to meet. So just to give you a little background in case you're not familiar with Zeus or Zbot or WNS Poem or whatever your AV company decides to call it, it truly is the #1 crimeware toolkit in use today. Actually, I'll go to my next slide early. Dancho Danchev made this great tweet the other day, or last month actually, saying that there's a monoculture in the cybercrime ecosystem thanks to Zeus, and he's very much right. There's everything you see is Zeus, and if it's not Zeus, it's probably just Coolface or one of the other big ones, and then a whole bunch of random stuff. If you look at the volume of Zeus out there, it's just absolutely ridiculous. And the important part about it is it isn't a single botnet in itself. It's a toolkit that's used by many people, whether they purchase it directly from the Zeus authors, whether they found a leaked or stolen version that they're using, which is very popular. But everybody's setting up their own servers themselves, their own command and control servers, and making their own bots on their own, and distributing these however they see fit. So oftentimes when I read about a new Zeus campaign, it's probably a whole new group doing it. It's really hard to attribute who's doing what with the different Zeus campaigns going on out there, because there's so many of them. But I would say that outside of the few big ones we've heard of, like the Never botnet earlier this year, which is just one organization's Zeus campaign, and some of the other big ones whose names I don't really recall right now, there's probably a lot more people doing it than it sounds like. So I would really pay attention to that when you're reading the news, and be aware that there's more than just one botnet out there called Zeus. But what it is it's primarily focused on stealing banking info It can steal anything you want. Whenever I demo it, I have it stealing a sock puppet Hotmail account, which works just fine. It can configure it to steal from any website, but pretty much everybody who uses it is trying to steal banking information. And it's really easy to configure. Anybody who is familiar with HTML really can customize it to do whatever they want. They have these things called web injects, so what it does is it intercepts the HTML being rendered, so you can say, oh, well, I see the Bank of America username and password, throw in a field for the debit card number and the CVV so I can get that too so they can log in, and it really just takes that data. It looks seamless on the page and reports back to the user. They do a lot of updates to make sure this stuff keeps working and works well, and it really does. A lot of data is stolen through Zeus every day. So to get back to more to how we're going to be using this, here's a sample configuration file from a version of Zeus 1242. It's a little older now, but it's still pretty relevant. There's 4 lines here that are of interest to us. They're the URL lines: config, comp IP, loader, and server. This is how you would normally set it up for a normal Zeus configuration with the default parameters. I'm using the domain of badguywalmart.com because that's where everybody goes to buy their malware and their toolkits and whatnot. And then we have the couple things in there. The config.bin is a configuration file where the bot will go update itself and get more information for what it's supposed to do. And gate.php is the actual command and control page where bots will check in and let the command and control server know, I'm alive, here I am, here's my information, here's some data, stuff like that. So where does Tor come in? Let's get back to where we're supposed to be with this. Zeus on its own doesn't support proxies. We can't just say, oh, just go to the .onion domain and hit our hidden service. That doesn't work at all. And Zeus only allows for regular URLs. Pretty much anything you can hit normally with your web browser is what it's looking for. It doesn't have any kind of proxy support, not the Windows proxy or anything. So we need a little intermediary solution here. And there is one that is free and works pretty well. It's called Tor2Web at tor2web.com. What this is, it's not affiliated with the Tor project at all. It's a third-party tool put up by some individuals whose names I've neglected to include on the slide. They're at the bottom of the web page if you want to check it out. And what it is a web page that will redirect requests made to tor2web.com with the right .onion hash and send it along. They'll send along through Tor themselves and return you the results. It's just like any other proxy. They also provide scripts so you can set one up on your own. So if you say, well, I like Tor2Web, but I don't trust them, I'm going to stand up my own and do all this myself. It's pretty easy to do. It's just a couple of configuration options: Privoxy, Squid, Tor, obviously, and one script they provide, and that's about it. So the way we're going to be using this is we're going to be doing the command and control over Tor2Web. So what we want to do in the Zeus configuration we just saw a couple slides ago is configure the bot to connect to that URL there. So what you'll see is the first part of it is the hash from the .onion domain .tor2web.com. So that would be, if that's the right hash, that'd be your command and control server. So what will happen is the bot will connect to Tor2Web because it just sees it as a regular URL, and then be directed through them to the hidden service at the .onion domain, which is our command and control server. Very simple and very effective. So as I mentioned, here's the main script they have, and all it really does is reformats request to Squid saying, hey, where it says tor2web.com, make that .onion and go through Tor. And then when it gets the results, it returns it right back to you. Really simple. The configuration for it is really hardly more than this script alone, so very nice. So I'm going to attempt a live demo of how this works. I've been fighting with this all day today, so I'm not too confident that it will actually work. So we'll pretend it does if it fails. I just want to tell you about the setup I'll be using. I have Zeus 1241, I think that's the right version, which is from about mid-2009, give or take. It's an older version now, but it's one that's been leaked, and it's easy to find on the internet, so you can just go and find a copy of it and make your own botnet. That's nice and convenient. For the command and control server, I'm just using a regular Ubuntu server setup with the LAMP package installed. I'll be running a hidden service on port 80, nothing too special, just like any other web server. For the host I'll be building the Zeus binary on and executing, I'll be using Windows XP SP2, which I'll go through the configuration files on there. And if this all happens, we'll log into the control panel and see a bot that has gone through Tor2Web to get there. So I expect this to fail, but we'll see. So here's that. Okay, I have to get on the network first. this is where I've been having problems all day. As I've been disconnected from the network, I've been having big problems getting everything to work right. So bear with me for a moment here. This is really exciting. If I don't connect in a full short time, we'll just pretend it all worked. And in the meantime, I'll show you the configuration file. So this is the configuration file we hopefully will be using. Is that okay? Oh, that's probably a bit big. All right, so here we have the same thing we saw before with the config and server, but what we have here is simply just putting in the TorWeb URL. Nothing too fancy, nothing that exciting, but it's effective. And am I connecting at all? So what I've done earlier is I've actually built the right version. This is the Zeus builder for version 1242. I was off by one. The current versions look very similar to this if you hadn't seen it before. This is what they're paying $4,000 for, this in the web control panel. When you click, so that's a nice thing too, where if you actually have Zeus installed on the system, which they consider spyware, you can click a button and remove it right from the system. But I'm clean, fortunately. So, and this is the builder, very easy. You just click build config, and that builds the config file, which that we saw in the configuration file. Just load that up onto the Zeus command and control server. I've done that ahead of time. But it needs that to know where to go download it. It doesn't even have to be on the same site that you're actually hosting the control panel on. It just has to be available somewhere for it to download. So you can set up, say, another hidden service on another box somewhere and put your config file there. As long as you have the right URLs, it'll know where to go to pick it up. And then when we build the loader, this actually builds the bot executable itself. Oh, I'm on the network. Let's see if we can do this. So as you see here, we have it's probably really hard to read, but we have the URL config and the URL comp IP, where we have the TorWeb URLs we saw before. So it knows where it's going, and let me see if I can get the rest of this working. So we'll restart Tor, and hopefully this will all just work. So I'm going to execute the bot now. We can confirm where the builder says, oh, we have version 1242 installed. Fancy that. And we'll go into Firefox and see if we can get to the control panel. If we do, then there's probably a good chance this worked. If we don't, then oh well. So we'll give this a moment. So it is ultimately going through Tor, so it isn't the fastest in the world. Tor has gotten a lot better recently if you haven't used it much. You're still giving a performance overhead, but really the way I look at it is that's a small price to pay for actual anonymity, and definitely worthwhile. This will probably work best if you're using a smaller botnet, maybe a couple hundred hosts, but if you have a much larger one, this probably won't work out too great where you have a single host hosting all your bots. So we'll give that a moment and see if that works. Probably not. Actually, we'll just come back to that later. We'll move on. So I'm sure that'll fail when we go back to it, but let's assume it did work for now. So there's strengths and weaknesses to this approach. The strengths are, like I said, it hides the command and control server. The only way you're going to find that out is if you can actually use some sort of attack, like presented in that paper I referenced earlier, or have some way to get into the server itself, make it expose its IP, which that's going to be pretty hard to do, I think. It'll be really hard to track down as a result. You won't know where you're looking for it. So with this being the case, hopefully the command and control server is virtually immune to being taken down. Now the weaknesses, I'm sure you've all thought about this ahead of time, it's really easy to filter this traffic. If you have any kind of HTTP filter or even you can block the IPs they're hosting it at, you're not going to be able to use this method. This is going to be really easy to take it out. And also trust, like I mentioned, you don't know what they're logging at TorWeb. You don't know if they're logging anything. I would hope they're not, by the way they're presenting their service, but you don't know that. So you probably don't want someone knowing where all of the bots in your botnet are coming from, because that may lead to them being taken down pretty easily. And running your own TorWeb proxy is definitely a better option. It's not really hard to do, but you need to have some place to run it. If I had some bulletproof hosting somewhere and I wanted to do this, that's probably where I'd consider running it, and probably not anywhere else, because I'd still have to give it a domain, or at least have an IP to point at, and it's still a single point of failure. It can be taken down, and then you're back to square one. So really quick, I'm just going to see if that worked. And no. Oh well. So what you would have seen if this worked was the Zeus control panel saying we have one bot, but we'll just pretend that's the case. Just apologize for that. It works much better when I'm on a more stable network. But with this technique, I want to rate this as I'm happy with it. I think it's a good solution, especially if you're using a toolkit where you can't really control what's going on. But I'm not going to let you know I'm happy. It's okay. It's not a great solution. You can do much better than that if you try. So when I was first playing around with this, the next thing that popped into my head was, well, what if I use the Windows proxy settings? That'll be pretty easy. I can just load Tor onto the system in a Polipo or whatever you want to use per voxy, and pretty much drop it on like you would any other piece of malware. Like along with my fake antivirus, I'll just drop Tor on there and run it however I need it to be run, and then just set the Windows configuration to use a proxy. We have the registry keys right there. You just set a proxy enable to 1, set your proxy server and the right port, and you're good to go. The problem with this is going to be very obvious to the user. The first time they go to Google, they're probably going to end up at the Czech Google or the German Google, and they're going to be like, I don't understand this language. That's not good. They call up their ISP. Something's wrong. That would be terrible. You'll be found in no time. So this idea I just tabled really quick. Do not want at all. So what's the best solution here? Well, the best solution is to actually do some work and build proxy support right into your bot. I don't know any bots today, or any malware in general, that actually supports using proxies. If you know of any, I'd love to know it, any toolkits especially, because it'd be great to use an example for this. But you need to have some way to resolve the .onion domains so they can connect directly to the hidden service. There's a few ways you can resolve the .onion domains, actually. We would have to load Tor like we saw in the previous example, and yeah, you could load Provoxy or Polipo if you wanted to, but Tor provides a functionality called map address, which is a, I don't know if it's still considered an experimental option in Tor, but it was in all the documentation I saw, where you can put into your config file the option map address, give it a local IP like 10.0.0.10, and the onion URL you want it to go to. And then you can just reference that local IP and go to it directly. So you don't need to have any kind of middleman to actually resolve the .onion domains for you. So this is really great. So a nice functionality to have, especially since we're probably going to be accessing a limited amount of .onion domains as it is anyways. So what we'll have to do in order to make our bots do this is add in at least SOX 5 support, or I guess you could use SOX 4A if you really wanted to. And that will be a bit of work. It's not, it's not trivial, but it's not too hard to add in. So we'll have to, the bot authors will have to step up their game a bit and actually provide this kind of support into their bots. So here's what I like about this. The traffic is going directly from the host to the destination in Tor. There's no middleman like we saw with Tor to Web. There's nothing you have to worry about there. It's going to go straight from your browser to the Tor proxy to the rendezvous point to the hidden service and right to the web server itself. You're not using exit nodes. You're not involving anything else where your data could be sniffed. It's going to be very hard for IDSs to pick this up. And this works for more than just HTTP, where Tor to Web was really just for web-based bots. This will work for IRC. This will work for pretty much any protocol you can think of. If you want to roll your own custom command and control protocol, this will work just fine. And I think this would be very hard to stop. I was trying to come up with what the options for this would be, and I really only came up with two. One would be just to block Tor traffic like we see some countries trying to do, and I don't think that will actually work too well with this. I just don't see, there'll be a lot of rules being in place, a lot of people trying to block Tor, and I just don't see people wanting to do that. And then the other would be considering Tor to be a virus. I actually ran the Tor binary through VirusTotal to see if anybody was doing this about a month ago, and no one was. So that's good because it isn't a virus, but I wouldn't be shocked if a result of that if some people are now. I haven't checked since then. But I just want to see either one of those happening on a large scale to make it to have any kind of impact where a bot that would still be reachable or possibly be able to check in with their command and control server. Now, I do see some weaknesses with this too. It's going to require code to be added to bots. So say take Zeus, for example. They're not just going to be able to plug it in right away. They're going to have to probably build it in as a new feature request for a new version and do it that way. So, and this isn't really accessible to people who are buying it today either. If you're just buying the kit, you have no idea how to code most likely. Or if you do, it's not in C or whatever language Zeus is actually coded in. And like I said earlier, we're going to have to load Tor on the system and run it. Where that's not hard to do, it's still another step that will have to be taken in order for it to actually work. So it's another thing you have to worry about. If you're not loading the malware on yourself, you're paying someone to do it, well, you're going to have to bundle things up nicely and see if they will do it for you properly. And then probably the biggest weakness with this would be if you're looking for any kind of anomalies in your network or looking for traffic changes, because while you won't be able to see the actual command and control traffic itself, you're probably going to notice some bandwidth utilization increases on servers that are actually doing it and whatnot. So that's probably that'd probably be the best way to pick it up. I don't know how many people are actually doing this today. I know a lot of large corporations are, and a lot of them aren't. So it's probably a hit or miss way to check it out. And some of the changes, if you're doing, let's just say, using a hidden service for a spear phishing campaign, and you're using a service inside some network that you don't actually have access to, it might be such low volume you would never really get picked up. So that could be a problem. So for this solution, I give this my favorite image, where it's just complete overjoyed Pokemon hugging and crying. They're so happy. So I would say if you try to take this approach, you'll have a very low risk of being taken down. Probably close to none, unless people are just extremely attentive to their own networks. So that's how much I love it. That's us hugging in happiness. So one thing I didn't want to get into too much here, but it still is worth mentioning, are private Tor networks. Setting up a private Tor network is pretty neat. It's a bit of an involved process right now, having to set up your own directory authority and a whole lot of other stuff. But it's great if you're really paranoid and want to stay off the public Tor network, if you're afraid someone somewhere might figure out what you're doing. The nice thing about this, too, is it can actually be significantly faster than the public Tor network as well. You can track the sites or the hosts you're infecting, looking for how their bandwidth is. You can just do simple checks, for maybe some of those speed tests even. You can find out how good a connection is. And then you can just say, well, you have a high amount of bandwidth, you're going to be one of my relays, and keep your network nice and performing really well as a result of that. And also, blocking a private network will be significantly harder. There's no list of exit nodes that will be published. There's nothing that people will know unless they actually go and investigate the network themselves. So it'll be significantly harder to take down. I don't see how a smaller network like this, unless somebody went after it directly and really paid a lot of attention to what you're doing, would actually be able to take it down. So I'm going to change gears a little bit here again and talk about some other features that hidden services give us that actually makes this a really nice way to manage your command and control server. So as we mentioned much earlier, Tor uses public keys to communicate, to let the Tor network know how to get to the server. When it does that, it creates a private key on the server, as well as the host name for the .onion domain, and puts that on the system that the hidden service is running on. So what's nice about this is these are just files in the system. You can copy these and move these wherever you want and make it so if this server actually goes down for some reason, you can redistribute it to another. And another nice thing too is you can generate a lot of these keys up front. If you run a script and just say, hey, keep clearing out that directory and keep restarting Tor, it'll just keep creating new keys for you until you have as many as you like. So would this be the case, what does this gain us as far as keeping our servers up? Well, it gives us a great amount of resilience. So like we saw earlier in the Tor to Web example that should have worked, we had the one hash that was the hidden service onion domain itself. So what we could do with this is easily move this from one server to another. We could just copy the files, move it from the hidden service directory on one server to another, restart Tor, and now we have, the bots don't know any difference, but they're still communicating with a new server. So that's pretty nice. This allows us to keep our botnet up and running much, much longer than we would otherwise. And while there's a chance that if we move it, and if we move it frequently, we might lose some data that was captured that we never actually recovered from one host that we moved from, and that's a really small price to pay in order to keep the bots phoning home and actually communicating with you. And another nice thing too would be to issue multiple onion domains for your command and control, or presumably set up multiple command and control servers in order for Tor to connect back to it and not have to worry if one gets taken down and isn't able to reach it that day. This also could be a nice misdirection technique where you could give the appearance that the botnet is significantly larger than it is, especially if you swap domains in and out. We saw something like this with the ASProx botnet, like I mentioned earlier, where every few days or so they would swap in a new domain for their command and control and age older ones out. Because the older ones, if they weren't taken down by the registrars themselves, sometimes they were taken over, sometimes they just weren't functional anymore. I don't know if the people running the botnet actually took them down themselves or not, but they aged really quickly, and the older ones were pretty worthless after a couple weeks. So we could do a similar thing here where we can lead people along saying, oh, here's our command and control, and then every few days put in a new .onion domain and to inform the bots, here's where you're connecting now. And since we can generate as many as we want, we don't have any limitations like dealing with registrars or anything. We can just generate tons and tons of these, roll them all out, maybe only use a couple, but then people have to watch them all and be aware of what's going on. Similar to how we saw a configure work, where it would have the randomly generated domains every day, and only a couple of them would be registered, maybe not even every day, and be used to communicate. So we can do it in a nice similar scenario like that with this here pretty much for free. So we talked about having your bots running Tor themselves in the best case scenario. So if we have Tor on there, we could do a lot more interesting stuff, like running hidden services locally. If you're familiar with Zeus's back connect model, this allows people to connect back to an affected Zeus host over RDP, remote desktop, VNC. You can even run a web server if you wanted to, and have it behind a hidden service on the affected box. What's nice with this is you can have it do a whole lot of things. With the Zeus back connect model, they use that to connect to a host that's been infected in order to make use of certificates in the browser for online banking. So what they do is they'll have people log into a remote desktop on a host and say, okay, well, now I can log into your bank account. If I have your username and password, then it really doesn't matter. Your bank's going to accept me as it is. So, and also another nice thing you could do is actually use this to distribute updates for your botnet. If every host you have infected is a web server and hidden behind a hidden service, you can just say, okay, well, here's the names of the hidden services that have the updates. We're going to have you connect out to these guys, get your update, and with that update we'll have more hosts that are doing it. So providing updates for tomorrow or the next update, whenever that may be. So it's a nice way you could actually model your botnet around Tor itself and use the hidden services to your advantage. And ultimately, like I mentioned earlier, NAT's of no concern here. If you have a host infected behind a router or a firewall or whatever, if it's talking on Tor, it doesn't matter. It can do this. So a few other thoughts. Since we're all running Tor, how would nice would it be to turn them all into relays? This is just something to pose out there to see what people think. There's an increased bandwidth in Tor overall, especially if you have a pretty sizable botnet. I don't know if it'd be worth it or not, but it could be pretty interesting to see. And this could have really positive effects for your botnet if you can actually increase the speed of Tor in any significant way. That'd be an awfully large botnet, but that could be a neat project to do if you actually have that kind of resource available. And on the other side, how about turning them all into exit nodes? I thought about this for quite a while to say, okay, well, this actually makes sense. It could be cool if you have a majority of Tor exit nodes and actually be able to control traffic going through it, or sniff the traffic going through, like we saw a few years ago with the people finding embassy emails and other documents by sniffing Tor exit nodes, which is, of course, a bad thing to do. I wouldn't encourage it, of course. But it's probably not a good idea. As enticing as that may be for what you may learn, you'll be exposing the identities of your bots, so I would really recommend against that. You don't want them popping up on the Tor exit node list and having a lot of attention being drawn to you as a result, especially if they all start to go up with say a drive-by download campaign that really takes off one day, your botnet increases by a couple thousand hosts, and it just happens to be a couple thousand exit nodes that stand up that day. It'd be pretty obvious. I don't think that's a very good idea. So, we get to the conclusion here. As we almost saw with the live demo, it's pretty trivial to get existing HTTP bots working with Tor. Yeah, there's a risk to it, but if you're really desperate and you really want to keep the command and control server hidden, this is a pretty good option. It's a pretty easy one to set up too if you're able to get Tor up and running on your server. And it's possible to get a lot more protection easily if you actually have the source to the bots by adding in SOC support. So it's just really a nice alternative to have. This, of course, isn't really something everybody's going to do, but if you can do it, it would be really nice to have so you can protect yourselves. Keeping a command and control server up is easier if you do this, hopefully. Having it anonymous would mean you're less of a target, or if you are a target, they're going to have less of a chance of finding you and taking you down. And actually controlling bots with a hidden service, like we talked about with the back connect stuff, would be pretty beneficial. This would be something that I think a lot of bot authors out there would be interested in providing for really no additional cost. And on the other side, defenses of this, I hope that you'd see that they do exist. It might involve looking at your network and looking at your data more than before, or a little differently than before. And it's probably not going to be easy to find this stuff. I mean, finding the Tor to web stuff will be easy, but finding bot using a SOX proxy probably won't be. So I would actually advise you to check things out, keep your eye open for this stuff, and if you actually find anything, let's talk about it. Let's see what happens and try to find out how people are actually doing this stuff. So that's all I have here. I'll be happy to do Q&A. I don't know if we have much time left here. I'll be in the room across the hall, definitely. And if you want to contact me otherwise, there's my contact info. And That's all I've got.